This is 9.6 The Converse of the Pythagorean Theorem. If the equation a squared plus b squared equals c squared is true for the side lengths of a triangle, then it is a right triangle. So we're doing this a little bit backwards than what we did the first time we were looking at the Pythagorean Theorem, where we knew it was a right triangle and found the side lengths. This time we have the side lengths and we're checking to see if we get something true to verify if it is a right triangle. So we're going to determine whether it's a right triangle or not. So here I have my triangle, and I like to set it up always with A being the smallest side, B being the middle, and C is the longest. C has to be the longest, and it is always by itself on the one side of the equal sign, because C is the hypotenuse, and it has to work this way. So just to make it simple for myself so I know which is which, A is always smallest, C is always biggest, and B is in the middle. So to set that up, I would have 9 squared plus 40 squared equals 41 squared. Then I get 81 plus 1600, and simplify that to get 1681 equals 1681. So yes, this is a right triangle, because I got something true, two things that are equal at the end. For this triangle, I would plug it in as, you could do 16 squared plus 12 squared equals 24, as long as the longest side is by itself. Then we get 256 plus 144 is 567, which would be 400 equals 567, and we know that is not equal, so no, this is not a right triangle. I have a triangle with sides 12, 13, and 15, and so I'd plug that in. 13 squared plus 12 squared is 15 squared, so 169 plus 144 is 225, and I get 313 equals 225. That is not true, so that's not a right triangle. So now we're going to look at when we are given coordinates and see if they form a right triangle. So in plotting these, I get this blue triangle for 1, 1, 3, 5, and 3, 0. So I can count this one because it's straight vertical, and that would be 5, to go from 5 down to 0. And then I need to find the length of this bottom side from A to C. But it's on a diagonal, so I can't just count it because it's not going to be accurate. So I make a little triangle and use the Pythagorean Theorem to find this one, and I can find A. I make it a right triangle, so that would be 1, and this would be 2. So I have 1 squared plus 2 squared is c squared, so that gives the square root of 5. And I'm just going to leave it square root of 5. I don't want to approximate what it is unless I absolutely have to. So for now, we're going to leave it as square root of 5. And then I need to find this AB length. And so I form another right triangle on the outside here. And this would be a length of 4 and a length of 2. And when I plug that in, I'm going to get the square root of 20 is C. So now I have square root of 20, 5, and square root of 5. Now I'm going to take those and plug it in to the Pythagorean Theorem to verify if this is a right triangle or not. So that would be square root of 5 squared plus square root of 20 squared equals 5 squared. Squares and square roots cancel each other out. They are inverse operations, and so that just leaves 5 plus 20 equals 25, and 25 equals 25. So yes, this is a right triangle. And let's do one more. Alright, you design a football play in which the player runs down the field, makes a 90-degree turn, and runs to the corner of the end zone. Your friend ran the play as shown. Did he do it correctly? So he did the blue part, started here, ran, turned, and then ran to the corner of the end zone. So the graph and this blue part would be given in your problem. The problem with this one is all of these are on diagonals, so we need to form right triangles on the outside to see what these side lengths are, and then we're going to use the side lengths in the Pythagorean Theorem. Just like the one before, except we have to do these triangles on all three of them. So here, I would count to go from 30, 20 up to meet this y value at the start is 50. So from 20 to 50, that's a length of 30. To go from 30 to 60, that's a length of 30 as well. So I would plug those in to get 30 squared plus 30 squared is c squared. So 1800 equals c squared. So this is the square root of 1800. And like we saw before, we're just going to leave it as the square root because I know that when I plug it into the Pythagorean theorem, the square roots are going to cancel. And that's going to work out really nicely for myself, and I'm not going to have to approximate and do extra work that I don't have to. So now for this bottom one, this would be 50 by 50, and so I plug those in to get square root of 5,000 is c. And then for the orange one up here, the part that you didn't run, but we need to find that to see if this is a right triangle, I would get 20 squared, 20 here, plus 80 squared equals c squared, so that's the square root of 6,800. Now I have all three side lengths, square root 5,000, square root 1,800, square root 6,800. And since they're all square roots, the largest number I have is 6,800. So that one's going to go by itself on the right side of the equal sign. And square and square roots cancel out. So then I get 1,800 plus 5,000 is 6,800 equals 6,800. So yes, this is a right triangle. He did run the play correctly and turn at a 90-degree angle.